Okay, so here's literally the question that I had this morning. It's a situation where the population grows exponentially. Population when t equals 20 is 200. I think it's 400. Doesn't matter. No, 600. Just trying to remember the numbers. Wouldn't matter. And population when t equals 40 is 1,500. Okay? Now there were 4 questions that this student had to answer. And one of them was, okay, what was the population when t equals 0? Turns out you don't need to get an exponential model for that one. Another one was, what's the population when t equals 80? Well, that one's easy too. Because bottom line is, this is 2.5 times as big as this. So when t changes by 20, population, when t increases by 20, population will become 2.5 times as great. Which means that when t is 0, this is 2.5 times the t equals 0 population. So you're going to divide this by 2.5 and find out that t equals 0, population was 240. Then what's the population when t equals 80? Well, you're going to have two 20-minute, or two intervals of 20, whatever the units are, right? It's going to be 2.5 times as much when t equals 60. Well, 2.5 times 1,500 is 3,750. And another t equals 20 unit interval is going to be 2.5 times 3,750. And I'm not going to do that in my head. I can come out close, but I don't want to think that hard. Don't mind thinking that hard, but I don't want to take your time for me to beat my head and cry and moan and be in all kinds of agony, making you feel bad for me. You probably enjoy it. Okay. So I'm not going to do that, but you can see we could easily get that. Okay. So the questions are. Okay? You can reason those out if you know a little bit more about the properties of exponential functions. But the question is, what's the doubling time? How long does it take the population to double? Well, it's going to be a little less than 20, whatever the units of time are, because in 20 units of time, it increases by a factor of 2.5, right? So you could guess, maybe it's around 17, okay? But we don't want to guess, we want a pretty accurate result, okay? And then, when is the population?
Well, I could just do a bit of math or else my tutor will kill me.
10,000. Okay. To answer these 2 questions, here you can just use simple ratios. Here you need the function, so let's find the function. Okay, well, a graph of the function and we all know how to graph it. except I don't put a scale on it. I put a scale on it that fits the information we have. So at t equals 20, population is 600. So I'm going to say let's say here's t equals 20, and here's 600. Now what the graph, well, let's just, okay, now t equals 40, that's twice as far out. And it's got to be 2,500. So I don't have a very good graph because it doesn't look like this is 2.5, or not 1,500, not 2,500. It doesn't look like this is 2.5 times this. Still, we can kind of use this graph as an indicator. If you position these points just right, then the second point will be 2.5 times the first point. So I probably had to put my 20 a little further out. So I'm not going to mess with that right now. But just to depict it, I've now got 2 points. Whether it looks right or not, I'm going to call this 40, 1,500, and I'm going to call this 20, 600. Okay? Now, the exponential form, the general exponential form that we prefer to use for this kind of thing is y equals a times b to the x. There are other forms, and we've seen how you change from a b to the x to an e to the kx or an 2 to the kx form. We've already done that, but let's just stick with this simple form because we're just trying to learn to do the applications. Okay, so we get 2 simultaneous equations. You know what to do. You've done it. If you don't remember, well, you probably will. 2,600 means when x is 20, y is 600. And 40, 1,500 means that y is 1,500 when x equals 40. How do we solve these equations?
Turn them into log and then put them against each other? Like, get rid of...
We're going to use logs, but actually, we're not going to need to use logs here. If it was a power function, we'd need to use logs. Okay? Okay, so we have the equations. A, 600 equals a, b to the 20, and 1,500 equals a, b to the 40. We have to solve for a and b, right? What's one strategy for getting an equation that has only one variable in it?
Sorry, I was going to say just don't write it.
That's what people think eliminate a variable means, but I hope we talked about that. You know, I hope I made an impression. Okay, and I know you know better than that. What are you going to do?
Take negative.
Take a negative.
Multiply one of them by -1.
Not going to help.
Get rid of both of them.
If it was plus, that would work. Your a would end up being subtracted off, or you know, you'd add a to its negative, but that's not going to work.
Would you divide by a?
Okay, you could divide by a, and if you did, you'd get like b to the 20th is 600 over a, right? It's a legal operation,
But you still have a.
but then you'd have to say that b is at 1/20th power of 600 over a, and then you'd get B is the 1/40th power of 1500 over A, and then those two would be equal. The 1/20th power of 600 over A would equal the 1/40th power of 1500 over A, and that's obvious. You can solve that easily, right?
Sure.
You could solve it, but it's more complicated than it needs to be. Okay, you know the steps, and I think some of you would probably get it, but most of you would probably just have a nervous breakdown, end up committed for years. Okay? You just wouldn't want to deal with it. Although it's really just a simple application of the laws of exponents to solve that. I wouldn't wish it on you. Okay? Nobody deserves that. I don't think. Okay. Okay, yeah, I look like fairly deserving people. But deserving of good things, not that. Okay. So, we've done this. Anybody remember? There are two basic strategies we can easily use to do this. We just shot down every possibility you suggested.
I mean, earlier I suggested taking the log form of it, but
That's not a bad instinct, but if you do it, you'll be sorry. Okay? If you do it and really try to get it to work out, it could be nervous breakdown territory. I don't know. Okay? It's probably not the best strategy. Okay, well, I say either you solve for A and plug it in here, which easily leads to solution, or you divide the equation, one equation by the other, which will eliminate A. Okay, so I'm going to do it both ways. Okay, one way. And I just write first, that's from the first equation. That's totally obvious. Okay? So 1500 equals 600 over b to the 20th times b to the 40th. And they just solve that for b, which I'm going to ask you to do in a minute. Okay? That's one strategy. The other is
Oh.
1500 over 600 equals, well, 1500 is ab to the 40th, so that's ab to the 40th divided by 600, which is equal to ab to the 20th. Well, A divided by A is just 1. B to the 40th divided by B to the 20th is B to the 20th. Hope you know the laws of exponents. You probably wouldn't have survived till now if you hadn't. But just in case, make sure you know them. Okay? And then you solve this one for B. Or you solve this one for B. So go ahead, solve this one for B, then solve this one for B. And once you get that, see if you can go back and find A.